So one of the things we wanted to do for you guys today is show you something new and shiny. And what you're about to see is the first time we're demoing a new capability. So in many ways, this is the launch of this particular capability, which is the voice troubleshooting. And it came down to our customers who are really asking to go to other applications beyond web. So this is our first foray into other applications, and Juan is going to cover the voice troubleshooting and what is part of that package. So
yeah.
Hopefully you enjoy it.
Good morning, hello everyone. My name is João Tunes. I'm a software engineer at ThousandEyes. Let's see if we minimize the probability of failure here. Okay, that's different. So before I go into the demo, I'm going to start with a couple of slides showing up the basic VoIP architecture and what exactly we are testing here. Then I talk a little bit about the key use cases that you guys can use in your, within your networks. And then I go into a few screenshots of the app and show you the metrics that we collect and how we calculate the mean opinion score, and then I go into the actual demo. So just to start, how does the VoIP architecture works? So basically, if you have two people who want to speak to each other and they want to use the internet to communicate, they want to use VoIP, they can be the typical user scenario is where you have users in different corporate networks. So one user can be in the corporate network A, and the other one can be in another branch office, and the communication can go across the internet. And so it starts by establishing the VoIP call, and usually it's using SIP, a session initiation protocol. And then it checks if the user is registered at the SIP gateway, and then once the phone rings on the other side, the call is established. And then the whole communication is done through RTP streams between these two endpoints. And so they're basically two independent RTP streams that are run across on this network. At ThousandEyes, we're actually worried about the actual voice call, and at this moment we're not worried about how that establishing of the call is being performed. So we have agents on both hands, and we basically are measuring the quality of the voice call between agent A and agent B. So a little bit about the key use cases that we look at here with these voice tests. So two ways you can look at this. So one is you don't have VoIP infrastructure yet, and so you would like to plan it, and you would like to emulate how would that work in your within your infrastructure. And so before you even start paying for the VoIP servers and the SIP gateways and see how the actual network behaves, you can just set up these tests between different endpoints and check how the voice quality is. And you can think about the capacity and the scaling. You can tweak your network, the firewalls, the routers, the SCPs, and have a better sense of how the quality would actually be. The other key use case is that you actually have a voice over IP infrastructure, and you want to troubleshoot it. So you set up tests, and then if the voice quality drops, you can go back to those tests and see what happened. And you can correlate that with all the different layers that we provide in our product. Again, the tests that we provide here, they're in a single direction. So if you want to actually emulate a voice call, you would want to create tests in both directions. And we display all these kind of metrics that are relevant to the voice. So besides the mean opinion score, we provide the loss, the discard ratio, packet delay variation, and so on. We do require agents on both sides. So it's different on the other network tests that we don't require the cooperation of the server, basically because it's a UDP and RTP based connections. And we require that at least in each one of these tests, one of the agents is an enterprise agent. So, and ideally you want to locate these agents within your branch offices. So let's go and look a little bit about how the user interface of the
Question,
application.
actually, I may have missed this.
Go ahead,
Is it the same agent that's used for the other app performance monitoring?
Yeah, yeah.
Okay.
So the same locations that you already have, enterprise agent locations and cloud agent locations as
So
well.
enterprise, if you're paying $99 a month for an agent, you can do this as well as monitor applications, right?
Exactly.
Okay.
And they can run concurrently with the other tests.
So let me just clarify. So whenever we add a new feature, the agent self-updates. So as we add new features, especially in this case, a new type of probe, when the agent updates, suddenly the customers have that capability automatically in their agent. So they don't need to install anything additionally or do anything else.
So it's fixed,
Just gonna be
fee,
instantiated
and you get all the features, built in.
Right.
Okay.
Well, there's still two tiers of fees, right? There's a base level and
That's
then
correct.
a transaction capable level, right?
That's correct. Even though the code base on the customer side is going to be the same. So it's just a matter of, on our end, if we want to enable that or not, like control that level of features. But you're right, there's at this point there's two packages.
Okay.
Right.
Yeah.
Right. So all the agents are updated automatically, but if a feature is enabled or not depends on the
So
billing.
you're simulating voice calls between agents as opposed to
emulating,
you're not like collecting live data on calls, right?
No,
Okay.
no. So it's,
And can
it's actually an
you-
emulation of the voice call between the two.
Right.
endpoints.
And can you emulate like multiple calls
Yeah. So usually,
simultaneously? I mean, like almost like a load test. Like you indicated, like for testing an infrastructure prior to deployment, can you
Right.
actually do like 15 simultaneous calls? Or something
at this
like
point, we cannot make sure that all the calls are done at the same time. So we don't have like capacity kind of testing. But we do have it's like calls from multiple locations, like within the same time slice. So ideally, they should not affect each other. But for terms of you want capacity planning, that's one of the features that we're planning to think on a roadmap.
There's no way this integrates with Cisco IPSLA, is there?
No, not at this time. No.
Sounds a lot
Not
like
yet.
a parallel to it almost.
These are all synthetic calls, and so we have one agent on one side, one agent on the other, and we're using all those. So across the different tests that within the voice tests, so the path visualization and the network metrics, they're all using these RTP streams that with synthetic payload that we control. So the user interface is very similar to the other tests that we have. So we have on the right side we have a timeline, and then you can see. Depending on the metric that you select, the timeline changes. And you have the world map view with the different locations of the agents, and they're colored based on the, if it's a warning, if it's an error. And then on the left side, a few of the metrics that we have here. The quality of service that you request, so the DSCP, the differentiated services code point. So it's like Ricardo said before, it's important if you want to make sure the quality of service is correctly implemented. So you can check that against the received DSCP. I'll go there in a minute. Both that and the audio codec, there are settings from the test, so you can change when you set up a test, you can change what is the DSCP that you want to set a test with, and the audio codec. The codec will change the frame rate of the packets of the RTB stream and the packet size. And then based on all those metrics, we calculate the mean opinion score, which is a qualitative value between 1 and 5, so 1 being very bad voice quality and 5 being like a conversational quality. And we calculate the ratio of packets that are dropped by the network, the ratio of packets that are dropped by the jitter buffer. So the jitter buffer is a concept in VoIP, and it tries to minimize the impact of jitter, of the packet delay variation. So basically, the stream is delayed. The playback of the stream is delayed a certain amount of milliseconds. So packets that arrive a little bit later than when they're supposed to, they can still be played back. And you can use the 99th percentile of packet delay variation to come up with better values to use in this jitter buffer size. And so the packet delay variation, in this case 45 milliseconds, means that we got packets that were delayed 45 milliseconds. So if you have a jitter buffer of that size, you will be able to play back those packets that are really delayed. And the average latency. And then, so this is the general overview. If you then scroll down, you're able to see each one of these agents. and then all these metrics, and you can see, for instance, the received DSCP. So what is the DSCP that arrived at the other end? So if you have a router that is misconfigured and it's not respecting that IP field code, you can check there. Another cool feature that we have across our product, it's the X layer, as I think Mohit said before. So you can jump, like using the same time slice, you can jump to, for instance, the path visualization or the BGP route visualization. Let me just go a little bit into the mean opinion score. So we use the E-model from ITU recommendation, the G107 document, and it's basically it models all the different impairment factors that exist in a voice call. Some of these, they were derived mathematically from for the actual nature of doing voice calls over the internet. Others, they need some of the metrics that we calculate, like the latency in the network, the jitter buffer size, and some are really dependent on the codec in question. And so once we put all these numbers together and we calculate the transmission rating factor, then we're able to map that R factor into the MOS, into the mean opinion score, and then we can have that value that clearly symbolizes the quality of the call. So let's go now to any questions so far?
A question about the agents, and I may have missed this earlier if you've already covered it. Are we looking at software only, or do you have any kind of hardware device or appliance that can be an agent as well?
No, these are all software.
Okay.
That runs on top of the agents.
So I was envisioning from a VoIP monitoring standpoint a campus environment, maybe it's a university or something like that, where they've got 200 buildings. They don't have servers, VM environments on all those sites. Would it be possible to leverage this as an application on some kind of a low power device like a Raspberry Pi or some other kind of small micro PC type of thing?
Well, I guess you can, if you can run the agent on a Raspberry Pi, you can definitely run this voice and other tests as well. Yeah.
This is my own ignorance, but are there any phones out there that allow sort of the installation of agents like that? Sort of like a thin kind of Linux-based deal?
Not that
I assume there are,
because
because that would be a pretty good platform, right? Because that's the single source of truth for all that. That's where the voice is going. So that'd be
Software-defined voice.
Oh God. I didn't say it.
Typically the phones, there's not really a way to embed.
Most, I assume, yeah.
Yeah, there's really not.
On those agents, though, could you define your own applications? So you built in the intelligence for voice, obviously, but if a customer had multiple branches and they wanted to look at internal apps, could they define what they wanted to monitor?
No, so I think the question is whether you can, because we have web and voice on the application layer right now.
Right.
The question if there's a custom application that uses some other application level protocol, can we define it? The answer to that is no, but what we have done in the past, and I'll give an example, one customer who wanted to monitor their mail application, their SMTP servers.
Right.
What we do have on the test is you can monitor any TCP port. So from a network standpoint, you can basically characterize the network layer completely. And so in that customer situation, we set up a test to the SMTP port, which gave them the network side, even though the application handshakes were missing. It at least let them understand whether the network has a problem.
So you can do layer 3, layer 4, but no L7.
Yeah, right.
Okay, yeah, cool.
Yeah, but we'll cover some of the key ones. We're definitely tracking applications that are trending towards more usage. Okay. So voice was one of the ones that we've seen a lot of pain in.
Is there currently a way to send a string, or is it literally just open a port, the port's available, things are okay at this point in time? So like F5, with a big IP, you can say, well, send this string if you receive this, the test's okay.
Not at the layer 3. We can do a lot of stuff at the web layer where you can send custom stuff. At layer 3, it's really like establish a connection and then make sure you can track the network behavior from an end-to-end standpoint, which. The challenge is if you have an application that runs UDP, then we have a problem because you need something on the other end to terminate the connection.
All right, so let's go into a little bit of a demo here. I'm going to start with how to create a test and what are the settings that you came up with when opening that page. And then I'll go through one of the shared links to show you like an interesting use case. So to create a new voice test, so you go to add new test, you go to select voice, then you create the test name. Like I said before, so here we need two agents. So we need a target agent, and we need to select agents to target that target agent. So one of these endpoints needs to be enterprise. So I'll just go here. We have some of these interesting labels, so we can just select enterprise agents. So we can select any agent that we want, and you go here, and then we can select any sort of agents that we want to from different locations. Just an example here. So this will run every 5 minutes, but you can change the frequency of the tests. And then here on the advanced settings, you can select if the server has different interfaces. You can select the right interface to which you want to target. You can change the port where the server is going to listen. We have different codecs here that you can experiment with. You can change the DSCP value as well of the test, and the jitter buffer size. So again, it's going to change how the mean opinion score is going to be. And you can also select to collect BGP data or not. And then, so once you create a test, I have a shared link here with some. Let me go to the voice. So in this particular test, we are targeting New Jersey, and you have all these locations here targeting that agent. So the agent is here. We can zoom in, and we see the target there. So at this particular point in time, everything is green, so everything is fine. But there's like a little bit of a dip here. So we can just click on it. And here you can see, so the average MOS score dropped. For this particular codec, the maximum MOS score would be 4.41. It's hard to read from there. So we got a value of 3.85, so there's a little bit of a dip. There's an average of loss of almost 3%. And if you scroll down, we can see that most of the agents are behaving really well, but then 3 of them, there's like a high loss. So you can see here, New Delhi in India, 80% loss, São Paulo, Brazil, 22, Denver, Colorado, 23. So we know there's something related to the loss, and that's what is affecting the mean opinion score. And one of the cool features that we have at ThousandEyes with our product is you can just go here and jump right into path visualization. And here, shows you like a bird's eye view of all the hops that are involved, on the path between all our agents to the target. And right here, we have like really highlighted one of the nodes, which is one node with loss over 25%. So we can actually click here and select the node. And once you mouse over it, you can see that there's a loss of 27%. So. And this actually is a node that it's common across those 3 agents. One was not affected, but the other 3 were affected. And this can actually tell you exactly why did you have that drop in the voice quality. Other cool features that we can see here, and again, the path visualization for the voice is actually using RTP streams, and so they're following the same path that the actual voice call would follow. And you can actually look at each one of these hops and see what is the DSCP that hop returns for our traffic. So you can see that we set this up with expediting forwarding, and it's not being respected. So it's being changed to best effort, which is the default on the internet.
You're able to see where the marks are getting changed?
Yes. Yeah. So each hop, you're able to see what's the DSCP that hop received.
That's pretty awesome.
Yeah.
Can you explain how you're seeing that? That's
Explain this magic.
Right. So
we can never let you out of the room if we tell you that.
So I'm going to turn off the microphone now, and I'm going to cut the.
I'm exceeded.
So we for the path visualization we use the TTL, and the TTL expired, and when the packets come back, there's actually encapsulated the packet that was received. So we're able to see what's on the DSCP that each one of the hops received.
I guess it's the next hop that's sending back the remarked packet to you.
So each time one hop is going to send you a packet because the TTL is going to expire. So that hop is going to tell you what was the packet that you received.
So in order to target one link specifically, you craft the TTL to expire at that point, get the packet back, and you iterate through the path.
Exactly.
So you get to your destination.
Yeah.
That is badass.
That's very cool.
Now, when with the path visualization like this, then you've got a node marked that 20% loss or whatever at a particular node. Now that 20% loss is loss of your synthetic voice traffic. Right?
So
that's sorry.
A calculation of this loss is a little bit different than on the endpoint.
So that loss is forwarding loss. So it's the loss that interface has on forwarding to the next interface. So it's not end-to-end. So meaning if that interface is forwarding 10 packets and 5 of them got lost, you'll see a loss there of 50%.
But how are you able to see that? Who did it? As far as
you're talking about the loss?
Yeah.
Well, we do that based on the probes that we send. So we expect to receive a certain fraction of the probes from next up, and we only receive a fraction. And by doing that, we are able to tell. We do, by the way, other techniques I didn't mention in my previous presentation of simplifying topologies. Because often in trace routes, you see the stars, and you don't know if the stars is actually a valid loss or a muted interface and never replies to any.
Well, I mean, the interesting thing is how much of my voice traffic, in this case, got lost or delivered, right? But
that is
all you can really measure on a where in the network is it getting lost is how many of the probes got lost.
Right.
Not
exactly.
the synthetic traffic you're generating, right?
Right. So we do different streams. So the stream that measures the end-to-end properties, like MOS, is a completely different stream.
Okay, got it.
So
This is.
I think the question is really, we're running several tests in parallel. And the idea with the network probes, and the reason we had to redo this was obviously it's UDP based, right? But for TCP, we would do the same thing for the web. There's a web test, which is the end-to-end server test, making sure the server is responsible. That's the HTTP server layer. In the page load, we actually load the page with a browser. Then we have an end-to-end test, which is a stream of end-to-end packets just to see what's the capacity and the loss and the metrics from an end-to-end standpoint. Then we have another test that runs on a hop-by-hop basis, and they all run in parallel. So the idea is each test gives you a different view of what's going on.
I see. So we saw before we were looking at the path page here. We saw 20% of the voice test was being lost, and then we clicked to the path page, and we saw what Delhi and Colorado.
Yeah, so the idea here was you saw MOS score drop, right? So the application test was having issues.
Okay, so now we
go
switched
into
to
the
different
end-to-end
test.
metric and see, is this a network issue? And you see that actually there was end-to-end loss as well.
Got it.
Now you don't have to go to the end-to-end loss. If you just want to go to the pathways, that's perfectly fine. But we give all the layers. So then you see the end-to-end, there were 3 sites having problems, 20% loss, but you don't know where in the path was the cause of the problem.
It wasn't clear to me that the loss of the test and then the loss on the within each node in the path was different tests.
So they're different tests, right?
Got
and
it.
Sorry, go ahead.
Yeah, but they all use the same, the same protocol and the same ports, so that we try to make sure that they follow the same path.
Yeah, we make sure the network probes are actually simulating application behavior. So you're actually characterizing, doing fault troubleshooting on the same paths that the real traffic would take, and not a parallel path.
Yeah, certainly the path matters, and I understand that. Yeah.
So this is another way to correlate on the same time slice a problem, and this one gives you a different point of view of the same problem. One was duplication, and you see the loss of the whole voice stream, the other metrics, and here you see like this hop here has this characteristic in terms of loss at this time slice. Any other questions?
Do you guys have any plans to sort of do some integration with workflow, as whereas you see one of these alerts and it triggers a packet trace, Wireshark, whatever you're using to capture? Because it'd be really cool to have these alerts and be able to line them up with, here's my packet capture that happened at this point in time. Do you see any kind of automation or?
Let's cover that in the closed session. We do have some work in progress there, but we'll definitely cover that up. Yeah,
good question.
All right. Any more questions on the voice stuff? Just to get a sense of feedback here, how many guys in the room are actually involved with voice troubleshooting in any capacity? All right. So the reason I asked you this is because I have our sales team looking at this view. So they're gonna capture each one of you guys and chase you guys in a bit.
You just sign up to be spammed.
Is that all?
Yeah, that's
Okay,
all. Yeah,
cool.
Michael.
So